Hello everyone and welcome to today's OSMINE webinar, Enhancing Safety with Epiroc's Collision Avoidance System. My name is Sam Sakasiris and I'm the National Membership Team Leader here at OSMINE and I'll be your host today. Before we begin, I'd like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people. I also acknowledge the traditional custodians of the various lands on which we all work today and the Aboriginal and Torres Strait Islander people that may be attending this webinar. I'm joined today by Eric Baker, Global Product Manager, Titan Collision Avoidance System, Epiroc Digital Safety Solutions. This webinar takes an in-depth look at Epiroc's Titan Collision Avoidance System, a cutting-edge safety solution engineered to reduce risks and save lives in mining operations. Designed for both surface and underground environments, Titan CAS integrates seamlessly with all OEM fleets using ISO 21815 standards and supports EMESRT Levels 8, 7, 8 and 9 compliance. The session will explore how Titan CAS leverages multiple fail-to-safe sensing technologies to detect vehicles, obstacles and personnel in real time. We'll demonstrate how the system enhances operator awareness, enforces geofencing and traffic segregation, and provides actionable insights into operator behaviour and site safety trends. Whether you're looking to improve compliance, reduce incident rates or future-proof your fleet, this webinar will show you how Titan CAS can be a cornerstone of your digital safety strategy. As we would like this to be an interactive discussion, please submit your questions as we go. At the end of the presentation, Eric will respond accordingly. It's a great opportunity to receive expert insights on the topic being covered. The Q&A button's at the bottom of your screen, so send through your questions as we go. You can also upvote other audience questions that you most want answered. We will try to get to as many questions as we can in the time we have allotted. We are recording this webinar and we will make it available to all attendees with a link to the OSMINE YouTube channel in the coming days. So with all that said, I'd like to now hand over to Eric to commence the discussion.
Good afternoon, everybody. Thank you for allowing me to share with you how Epiroc Titan CAS can enhance safety in mining operations. We'll be doing this by looking at a case study or a safety share and using that as the basis of explaining how Titan CAS can be applied. I'm Eric Baker, I'm the Global Product Manager for Epiroc Titan CAS. I'm based in South Africa, visiting Australia for the first time, so really excited to be here with you today. So I want to do a safety share with you, as we normally start all our presentations with safety shares. And this is from an unfortunate incident that happened earlier this year in Peru. Many of you might be aware of this, that this occurred. There was a fatality involved. Senior operations manager was fatally injured, as well as the drilling and blast superintendent was seriously injured. But there are many elements that led to this, and I don't have accurate reports on it, but a lot of hearsay and speculation states that some of the levels of control might not have been effective on this particular mine. Things like segregation controls, it's speculated that for this particular day, load trucks and light vehicles were allowed to be on the same haulage roads. The operator of the light vehicle that wasn't authorized, wasn't licensed to drive this light vehicle. And then we also understand there's already a collision avoidance system on this site, which for some particular reason did also not help to prevent this accident. So I want to tell you or share with you how Epiroc's Titan CAS can assist with safety on your operations. So we've got some key benefits. From the prior slide, it's obvious we want to improve safety, enhance safety, address collision risks between vehicles to vehicles, vehicles to obstacles and pedestrians. It's important to note that Titan CAS is OEM agnostic, meaning we can fit them to most mining machines. And then also it can be used in any mining environment, underground, surface, plants, or a combination of of these scenarios. Our technology stack consists of multiple technologies. We've got magnetic field or LF field sensors. We've got sub-gigahertz RF, GPS sensors, time of flight sensors, AI vision, camera type sensors. And we've selected all these technologies because they all have their advantages and limitations. And we believe that the combination of these allows for a fail-to-safe system that can be applied to all these scenarios, mining operations and different machine types. So this means there's a particular configuration that might be required on your mine site. So we can add different types of sensors. Top left, that's probably the most simplest configuration. And bottom right, you have a more complicated situation or configuration with sensors. But we work with our customers to decide what is the best solution and best configuration for their operations. So we go through a process where we start with a site visit. We've got some questions, we ask some background questions, and we try to determine the risks on site. Are there traffic management plans already in place that can assist? We look at where the risks are. Is it vehicle to vehicle, vehicle to pedestrian, vehicle to hazard? Then we typically come and do a bit of a demo with a kit on a couple of machines. Customer gets a feeling for the system. We get a feeling for the site as well. That moves over normally into a trial where we also then consider level 1 to 6 maturity of this particular customer. And we then start working through this process. I would like to just show you some of the complexities and the work that we typically do with our customers. I've got a Google Earth screenshot of a mine in South America, and this is just a small section of the mine. You'll see that at the bottom left there's a cross, the top right there's a cross, then there's a big whole road that looks like an S, and then a smaller S at the bottom. And for this scenario, there's already a lot of traffic management rules in place. When a vehicle approaches one of those locations marked with an X, they need to radio into the control room and ask permission to enter this area. Then once you have entered this area, only one vehicle type is allowed. So only light vehicles are allowed, or only haul trucks are allowed. There's only one-way direction. There's following distances, there's speed control. So there's a lot happening in this scenario that needs to be evaluated. And this is just one section. The same can be applied for underground mines as well, where vehicles and people interact. So you would take that scenario and you would apply EMESRT scenarios, the priority unwanted events. This comes from EMESRT. Thanks for all the good work they are doing. So you would look at these scenarios, you would do a risk assessment on them, and you would understand what are the following distance, what must be implemented, how can the collision avoidance system work holistically to solve this, to make this the safest operation possible. So you would do like I mentioned, a risk assessment. This is a very fictitious risk assessment, but it's to prove the point. You would look at all these priority unwanted events. You would rate them and you would state the risk is too high. And then you would decide which level of control can be applied to reduce the risk to acceptable levels. So I've now mentioned that the EMESRT and the levels, but maybe let me just jump into them quickly. So this is our representation of it, but it is the same wording as it comes from EMESRT. So there are 9 levels of control, each building on top of each other. And I've heard that customers expect collision avoidance to be a silver bullet solution. And my answer to that is, you can compare it to soccer or football and having a goalkeeper. Level 9 is the goalkeeper, and you can't play soccer with only a goalkeeper in your team. You need the full team to be available and all of them to perform optimally. So I'm going to use this framework to delve a bit deeper into how Epiroc's collision avoidance Titan can solve these or support these levels of control. So first off, we have, we don't do level 1, but we can help with level 2 and level 3. And I've got a snippet here of one of our animations. So I'm going to start with that, and then I'll talk to it.
Geofences around the mine site automatically enforce restrictions on machine speed, travel direction, and access to designated no-go areas. This technology also enables priority vehicle access to specific zones, enhancing organization and security.
So, sorry, it is a bit cut off short there. I have a QR code at the end of the presentation where you can just scan it and see or watch the full video or animation if you want. But it's clear from this that we help with setting up geofences, no-go areas, control intersections, have time-based access control. We can enforce following distances, speed, overtaking can be stopped. So all those scenarios I showed earlier with a Google Earth shot, we can help add layers of control on these layers. And if we move to level 4, again, with this Titan CAS solution with our HMI, which is our controller or LCD within the cab, we can also enforce certain access and licensing. Let me see if I can play it.
The Commander HMI 100 efficiently manages and controls mining equipment access. With license management capabilities, it controls equipment access, integrates with operator time and attendance cards, offers traceability and fingerprint verification. The system is fail-to-safe and continuously monitors all subsystems and sensors for proper functioning. Vehicle test stations can be deployed at strategic locations to collect data from vehicles and report the status of the system to a central server. Access can be controlled by these test stations to ensure only fully operational systems are allowed in controlled areas.
So I think there it's clear to see that we use our display as more than just a heads-up display for the operator. It's also a tool to use clock cards, biometric readers, and it logs all these events as well. It takes, we know who operated the machine at any time. That's all logged and downloadable. And then it also shows we can use the system to create access control with physical booms or prior, as we showed with geofences as well. Level 5, level 6, it's fitness to operate and operator compliance. So fitness to operate, that's where you look at fatigue and maybe intoxication. We currently don't have a specific sensor for that. We are launching a fatigue monitoring system next year. But for now, what we do is, part of the operating compliance, the checklist on the screen, and this is fully configurable. We can add anything in there. But typically, you could ask the operator, are you fatigued? Are you physically and mentally ready to operate? And they then would have the authority to say yes or no in that instance. And if there's any negative answers, then the system will not be able to be operated. So there are many things like this that can be implemented as well. And then, there it goes. The crux of the matter then when you get to level 7, 8, and 9. So level 7 is when you give the operator awareness. This happens in the range of the order of minutes. Then you get advisory controls at level 8. So you start advising the operator on critical hazards that's going to occur. And in level 9, when the operator could not adhere to these warnings, we can take control automatically of the machine and slow down and stop it. The video down here is a video where we make use of our navigation and tracking capabilities combined with collision avoidance to provide this full range of capabilities. So at the bottom right, you'll see a screen. That is what the operator is actually seeing. And if I get it to move, then you will see it starts warning. Level 7 makes awareness at about 100 meters. It tells the operator there's another vehicle in the vicinity. And then as it gets closer, we start advising it's now green, it's going to get red, it's close. And then in this instance, it wasn't needed to stop, so we could safely pass. But this just shows the complete range of Titan CAS that we cover all the elements within the system. So if we come back to our case study with this unfortunate incident, Titan CAS can play a supporting role through all the layers of control, and not only at level 7, 8, and 9. And we want to work with our customers to improve all the layers of control, because ultimately it also improves the level 7, 8, and 9 capabilities of our system. I promised a QR code. There it is on the right. You can scan that if you want to have better or see the full animation. If that doesn't work for you, you can also Google it. It's on YouTube. There are multiple videos about Titan CAS on YouTube. And then you can also visit the epiroc.com website for more information. Thank you for your time. I appreciate it. If you want to get in contact with me, you can send me an email directly, or you're welcome to scan that QR code to connect with me on LinkedIn. Thank you, Sam. You're muted, Sam.
Thanks very much, Eric, for the extremely valuable insights on the Titan CAS. It's now time for your questions. So let's get to those. So we've got a question. First one here is, are you searching for already programmed fatigue management systems?
We are currently developing our own system. But we are willing to look at other systems that are also available and to integrate.
Thank you. Our next question is, what is the range in line of sight and around the corner in the underground operation?
Actually, we use two technologies primarily underground. The first is the time of flight, and that we get typically 50 to 80 meters. It is limited to line of sight. And then, the low frequency or the magnetic field can range up to 20 to 25 meters. That's not limited by line of sight and can detect objects through or around corners.
Thank you very much, Eric. Next question, let's have a look. What support structure is in place for Titan CAS?
Oh, good question. Yeah, we've got multiple levels of support. Typically, we have what we call level 1 support on site. That is to do the day-to-day maintenance on the systems and do hardware swap outs. Then we have level 2 regional support, and that's a bit more advanced, and it can do analytics and help configure the system. And then finally, we have a level 3, which then goes back all the way to the product development engineers, who can give more detailed support and even add integration or new features if needed.
Thanks very much. Next question. For mobile equipment, does the Titan CAS require a specific minimum level of environmental lighting intensity?
I'm not exactly sure where lighting comes into this. If it refers to the camera system, then yes, to certain degrees, the lighting of the vehicles are good enough, but we've also seen the need to include infrared illuminators in some cases.
Thank you. Next question. Can the onboard be used with other CAS systems?
Yes, it can run completely independently.
Yes, another question about the lighting. Do we need good lighting?
So Again, I assume this is about cameras, but if you don't have cameras and you only have all the other sensors, they can work in complete darkness. It's RF-based, magnetic field-based, so you don't need light to see.
Thank you. In the presentation, would the approaching vehicle also be running CAS? Do they interact/communicate with each other?
In the last video, you could run independently. You need CAS on both sides to detect each other if you want the CAS level 7, 8, and 9. If you only want the awareness level 7, then you can run onboard independently.
Thank you. Next question. What measurement rate is used for the underground solution, and what is the maximum number of persons or vehicles in the vicinity?
Okay, now you get into details. So we try to at least detect within 100 milliseconds all objects. We want to do 20 pedestrians around 7 machines consistently. That's our targets. It's not always possible, depending on the environment, but that is what we are striving to do.
Thank you. Next question. Can you have a system with AI human detection cameras only with no CAS?
Yes and no. We prefer not to promote the AI camera as a standalone solution. It's a secondary technology. It's a backup for when tags are not available or for some reason not carried with people, or unauthorized access have been obtained to a site. That's where the camera comes in. Although we have promoted in some instances with very slow moving machines to have cameras around them as a primary sensor, but then we don't promote it as a collision avoidance level 9 system at all.
Thank you. Next question. How has Titan CAS performed in recent trials or deployments, and what lessons have you learned?
We have done some trials and deployments in Australia, Latin America, and in Canada. We've learned that operator involvement is crucial, especially in the beginning. Good training of the operators and running a phased approach, a structured phased approach to deployment is really important. And then, yeah, what we also learned is that some mines are more hazardous than others. More corrosion. So we have then also improved our product to withstand these corrosive effects by applying better materials and installation practices.
Okay, I don't have any other questions up here on the dashboard. I think we've gotten through all of the ones that were asked.
We're running an efficient system, Sam.
We are very efficient. Let me just quickly check that we've covered everything. Okay, well, if that's the case, we will look, if we didn't get to your question and you haven't thought of it to answer it during the session, please let us know and we will forward it to the Epiroc team for a response. I'd like to give a big thank you to Eric for your time today. Your insights are appreciated as always. Just a reminder, we have recorded the presentation today and we will send all of the registrants a link to access the video through the OSMINE YouTube channel. Thank you to everybody who's attended and we look forward to welcoming you to the next OSMINE webinar.
Thank you, Sam.
Thank you.